Hello, I'm Nanix, and this is part 5 of the Let's Make a Survivor tutorial series. In this part, we will be implementing object pooling for spawning waves of enemies efficiently, all using interfaces. Now we're going to set up pooling, object pooling to be precise. It's a much cleaner way to handle spawning and despawning of objects, keeping everything nice and optimized. To begin, we'll create a script here under core called object pools. Then under interfaces, we want to create a script. This one will be an interface called iPoolable. We'll open up the iPoolable class. We'll set it to an interface. And we'll begin. I'm going to use the tag hideInInspector here for a public variable called object pool of type, here's an issue. We need to actually use using unityengine.pool to use Unity's object pool. The confusion there is because I have another script called object pools and it's trying to autocomplete. We don't want that. And we want this to be of type iPoolable, so its own interface. We'll set this to pool, and we'll make this get and set. Next, we need to set up GameObject as the variable GameObject, and we just want to get for that. This is automatically implemented by MonoBehavior, so when we add this, it shouldn't even pop up in the current class, but we need access to it for what we're about to do. We're going to use default implementations for a few functions. This one called load, we want the game object and we want to set it active to true. We want another function called unload and we want to do the inverse of this, false. And then we want a method called release, within which we will check first to see if the game object is active self. If it is, we need to handle object pools handling the pool. So we'll come back to this in a moment. We need to set up the integration in object pools first, though. So, to do so, we'll open up that object pool script in the core. Now, we need to make this one a singleton. It's quite a standard pattern. We set this first as a public instance of itself. And then in the awake function, we just need to make sure that this is the only one that exists. So, if instance is not equal to null, and the instance is not equal to this, we've got a problem. We have to destroy it. Destroy it, okay. Otherwise, we'll set the instance to this. Now this allows us to just access this script anywhere from any other script. It's not generally good practice, but in the case of using something that instantiates object pools, it's perfect. Next, we need to add a nice little private variable here of type dictionary. Awesome, so that's automatically added system collections generic, with the key being an iPoolable, and the value, remember we need to implement unityengine.pool, being of type object pool iPoolable. So, if we pass it a key of an iPoolable, it should return an object pool of that same type iPoolable. And we'll call this pools. Really feel like I need to go for a swim. This needs to be instantiated, or initialized rather, as an empty dictionary. Okay, next, going to make a get function, going to make a find or create pool function, and that's it. Okay, we'll start with the find or create pool function. So, public void, oh no, it actually needs to return an object pool of type iPoolable. The function name is this, and we pass it an iPoolable called pool. No, we'll call this prefab. Okay. Now, because we're using an interface here, we need to do a little bit of work to get it into a instantiatable object. It's quite simple. First of all, we'll check to see if the pools contain a key for this prefab, and if they don't, we need to create a pool for it. So we'll go if prefab is of type object, Unity object, bringing it down to the base Unity object. If it is, then we can go pools.add the prefab as the key, and then we need to do the new Unity object pooling. So new object pool of type iPoolable, and this has some fun little functions in it. Just close that off there. Don't need to close that one off. So to begin, we'll use the alias create func, which is the function that's called when we want to create an object for this pool. We'll use an anonymous lambda iPoolable item equals, and we need to typecast this to poolable, and we want to instantiate the Unity object that we've extracted under the transform for this object pools script. Awesome. If I could spell. Then we need to set the pool variable. If you recall, over in here, we set up this pool variable, which is public object pool iPoolable, to equal pools with the key prefab. So that's this here, passing itself in through as the key. And then finally, we need to return the item that we've just created. Excellent. Next, we need to create an action on get alias. Same, again, using an anonymous function. This one, however, actually has a parameter, iPoolable item. So when we get an item from the object pool, we want to run a function on it. And we've set that up over here. It's this load function. So we go item.load. It's already typed as an iPoolable, so that will work. We need to then go action on release, which is when you want to return something to the pool. iPoolable item.unload. That same function we set up from before. Then the standard action on destroy. This generally won't be called, but it's good practice to have it here. iPoolable item, and then we run a standard destroy item.gameObject. Now there's two more aliases we need. One is collection check. We'll set this to true, and the other is default capacity. We'll set this to 16. So we'll always have a default pool of 16 objects in an object pool. Now, after all that, we return the pools with the key of this prefab. So if it doesn't exist, it'll check, grab the object, and then spin up a pool of those objects and return the pool with the key. We'll set up public iPoolable, since we want it to return a poolable, get, and we'll use the key, we'll call it prefab here as well. We'll then find or create the pool, just in case it doesn't exist. We don't want to throw a tantrum, so this will spin it up if it doesn't. Make sure I rename that. Return pools prefab dot get, because we're using the object pool get method here. This is returning, again, using the key, it's returning the dictionary object pool of iPoolables. So we're using all of the functions that come from here to handle the pooling. A little bit confusing, but it works. Now we need to jump back over here to iPoolable and actually finish its integration. Now that we have the functions, we can use something we've done before. If the pool is null, then we want to set it to object pools.instance, because it's a singleton, .find or create pool, and then we want to pass through this poolable type. Otherwise, if it does exist, we want to call pool.release, and we want to release this object. So this is using the object pool release method. If we jump into the object pool from Unity here, it's got some nice functionality. We've set up functions that run for the majority of these events. So you've got get, where it tries to get the object that is pulled. It either tries to get one that has been freshly released this cycle, otherwise, if it doesn't exist, it'll create it from scratch, or it'll just grab it from the list that exists there and remove it from the end. Then it calls the actionOnGet function that we set up and returns the object. The same thing with the release, it just adds it back into those lists. Quite clean. And so now we need to set this up so that we can see it in action. To begin with, I'm going to create a folder called prefabs. And we're going to drag our enemy down into the prefabs. We'll also do the same with the player. We're going to create an empty, we'll call it object pools. Drag this to the top. And drag the object pool script on there. Awesome. We need to jump into the enemy as well and actually make them iPoolable. So, same thing we've done here with iDamageable, we make them iPoolable. And then we implement whatever's missing, implement interface, which is the pool, which we know is automatically get or set by the object pool, so we can just hide this in the inspector. It just needs to exist. You'll notice it hasn't created any of the functions. You can override the functions from the contract here by recreating them, and it'll use the one that you create inside the script instead. So if I were to create a public void load, this will overwrite this here. For now, we don't need to do that. But what we do need to do is change the way that this death works here. We no longer want to destroy the game object. Instead, unfortunately, we have to do it this way because of the way that C# likes to implement these default interfaces. We need to typecast as iPoolable this script itself and then call .release. And that will actually access this function here, where we check if the game object is active. If it is, grab the pool. If it doesn't exist, otherwise just release it back to the pool. Okay. Lots and lots of things to get your head around. If it's very confusing, you can rewatch the video infinite times or just ask me questions. Okay, now we're going to add another empty, and we'll call this one Wave Manager. We're getting on to the wave management part of the video now. Inside scripts, we'll create a new folder called Managers, and in here we will create a script, not a shader, a script, mono behavior called Wave Manager. Hop into that. Okay, now we're going to set up a header zone. We'll call this one shared. Just going to prepare a few things here. So we'll make it a serialized field. We'll call it private. It'll be a shared float. And its name will be _ticks. Yes, _ticks. Then we need a private float ticks. And we'll make this a getter and setter. So get ticks.shared and set ticks.shared equals value, not false. Validation, no, value. That's the one, the keyword that's magical. We also then want to grab access to our player because we'll use them for spawning. So shared transform _player private transform player. We don't need to set this, we only want to get it. So player.shared. Okay, that's the shared variable set up. Then we want a header for waves, which we'll implement in a moment. We want a header for spawning settings, which we'll just set now. So we need a private float, and we'll call this one spawn radius, which will be the radius from the player that enemies will spawn at. We need a header to handle the tick logic, so ticks. We'll make this serialized field, private float tick rate. We'll set this to 1 by default, so 1 tick per second. We'll just duplicate that, and we'll call this one tick total. And we'll set it to 5 minutes, so 300 ticks. Make a private float called timer, which we'll use to calculate when the ticks happen. Okay, now we're going to set up a few things here. To begin, in awake, we want to set our ticks equal to tick total. Okay, so we're setting the timer to 5 minutes. Then in update, we want to increment the timer float by time.delta time, multiplied by the tick rate, 1 in this case, so it won't change. If we wanted to go double time, it would be 2. If the timer is greater than 1f, then we want to subtract 1f from it, because if we were to set this to 0, we'll lose the extra delta time that comes over the top if it ever overlaps. By doing this, we'll reset it to just -1 second, which is what we want. Then we'll call another function. We'll just call this tick. Yeah, called tick. Okay. Inside tick, we want to reduce the ticks by 1. And we want to grab the current tick in integer form. So equals mathf.floor to int ticks. Just in case there's, for some reason, half a second in there. Always sanity check your code. Now, before we do anything further, we do need to set up a struct that will handle our logic for the waves. So we'll go system.serializable to make it a serializable struct, public struct wave, within which we want to set up an enemy that we want to spawn. We want to set up an integer from what time? To what time? We want to set up an amount to spawn each time a check happens, a total amount on the screen that we want no more spawning to happen after, and the cooldown of when it should check to see if it can spawn. So this will allow us to use session-based spawning, which is a system used in other survivor-type games. Now we need to just implement it. But first, what we'll do back up here is we'll create that dictionary with wave as the key, since we've got the struct now, and int as the value. And we'll just keep this simple and call it spawned. We'll be using that for checks later. And initialize it. Okay, cool. Now, inside here, what we want to do is loop over all of the waves, check to see if they're valid. If they are, and there's an amount of enemies that can be spawned, spawn them. So to begin, we need to jump back up here, set up a serialized field, a list of waves called waves. Now we can implement. For each wave in waves, wave everybody, if the wave.from is greater than or equal to the current tick, and the wave.to is less than or equal to the current tick, so the current tick falls between the from and the to, and the current tick modulo wave.cooldown is equal to 0. So if this tick falls on that wave cooldown divisor, right there, then it's a valid spawn. Now to do the further logic, we'll just check if spawned doesn't contain the current key for this wave, we need to quickly add it. So we'll go spawned.tryAdd wave with 0 enemies. This is to avoid attempting to access it when it's not actually initialized. Right here. So we're going to try and get the value of the current key out of that dictionary. We don't want it out as current tick. We want it out as an int called amount. And if that's true, then if the amount is less than the wave.total, we are still valid. In that case, we need to set the amount to spawn. And we'll do that by grabbing the minimum between the wave.amount, which we set down here, and the wave.total minus the current amount. So, if 18 enemies have spawned and the total is 20, we don't want it to spawn 4 more enemies from amount, we only want it to spawn 2. So we get the 20 minus the total amount, which is 18, which would leave 2 here. And of course, 2 is less than 4, so amount of spawn will be 2 instead of 4. Then we just need to do a for int amount of spawn, and we'll make a function called spawn and pass in the wave. We'll do that now. Public void spawn wave wave. Okay, and we also need one called public void get random point. And we'll have a vector3 position. And finally, yeah, we'll pass in the range here. Or it shouldn't be range, it should be radius. Okay, so we'll set this one up first. To do this, we want to get a random angle. We'll just be doing some 2D logic here. So random.range between the 0, nope, so it should be between 0f and 360 degrees f. And then we want to multiply that by mathf, degrees to radians, so we've got it in radians. We then want to use mathf.cosine of the random angle. Whoa. Okay. And float z equals the sine of the random angle. And then we want to return the position, which has been passed through, plus a new vector3 with the x, 0 on the y, the z, multiplied by the radius. And we obviously need to set this to return a vector3. So this should allow us to get a random point at the edge of a circle from this position. Perfect. Now, for the spawn logic, we'll use vector3 spawn point, and we'll set this to get random point using the player.position and the radius, which was spawn radius from our settings up above. Then we want to instantiate the enemy, or rather call it from the object pool. Now to do that, we use enemy as the typecast, object pools, dot instance to get the singleton, dot get, wave dot enemy. And I'm just going to rename that. If you're using Visual Basic, there's a rename function. If you right click, you'll be able to see your keybind for it here. Mine is F2, and I'll just change that to spawn. It'll change the instance in all scripts in the entire solution. So now we're spawning the enemy, but we need to do a little bit of setup on the enemy. So let's jump over into the enemy script. Lots of jumping around this time. We'll just create a function down here. We'll call it public void spawn, and we want to pass in a wave manager.wave wave and a vector3 position. We'll jump back up to the top here. And just under here, we'll set a private wave manager.wave wave. And then back down in our spawn function, we'll set this wave equal to wave. So that's this variable that's on this script. We will run that initialize function that we set up earlier. We'll then change the transform.position of this object to the position. And there's one more step. We need to keep track of how many enemies have spawned. To do that, we're going to use some events. So we'll just jump back over here. Under core, we'll create a script, an empty C script, and we'll call it events. Jump into that. We're going to change it to a static class, and then we're going to have public static unity action, very similar to our input handler, and we'll pass through a wave manager.wave, and we'll call this on enemy spawned, duplicate it, and we'll call this on enemy killed. Let's make this cleaner. On enemy spawn and on enemy death. That makes more sense. Jump back over to the enemy, and then we'll run events.on enemy spawn, and we want to pass through this .wave. So that'll register an enemy from this wave spawning. In the same vein, just under here, before we release, we want to do on enemy death, this wave. Now we can have the wave manager listen for those events using the standard route, on enable, on disable, events dot on enemy spawn plus equals, we'll make a function called register enemy. It's not in existence yet. And then we'll Make another one called unregister enemy for on enemy death. Grab those, slap them here, and remove those when it's disabled. Let's create those functions now. Private void register enemy with a wave as the variable, and a private void unregister enemy with a wave. So many waves in this. Now these are just very simple. If spawned dot contains the key wave, then we want to access that and reduce it. Oh, sorry. For register, we want to increase it by 1. Do the same thing down here, but reduce it by 1. Now everything should be set up the way that I want it. So if we jump back over here, remove the enemy, jump into the wave manager, set it back to the origin of the world, drag and drop the wave manager here. We need to create a new variable, shared variable of type float, called timer. Place that under this shared float. Use the player 1 transform. And now we need to set up the waves. So, like I mentioned, these are sessions, which means that they're going to run whilst the settings are true. So we can drag our enemy into here, and we want this one, say, to run from 300 to 0. We want to spawn 3 enemies at a time, and we want no more than 10 of the same enemy from this wave to exist on the screen at once. We'll do this in increments of 2 seconds, or 2 ticks rather. So with all that, we should now be able to save, press play, yes, so they're spawning. Ah, but they're not spawning at the offsets that I want. They all seem to be spawning in the same location. Jumping into the prefab, I'm just going to zero that out, so they'll actually spawn at the origin of the world. And I need to jump back over here, and this is the issue with jumping between scripts all the time. We're instantiating the enemy, but we forgot to do enemy.spawn and pass the wave and the spawn point through. That will resolve that issue. Now if we hit play, voila! They randomly spawned from around me. Ah, that's something we need to fix up too. Stopping them from spinning on the spot. So we'll do that. If we jump into the enemy script here, what we're looking for is when they are telegraphing, they're holding. Ah, and the hold is not doing a look. Should just be calling look, which will reset the angular velocity, which stops them from spinning. And if we pass through a vector 3.0, then it won't actually look anywhere but where they're currently looking. But what I want to do for that telegraph, just quickly, we'll actually remove that. We'll make them do the standard move of vector 3.0, and we'll just adjust this little look function here. Float rotation multiplier. We'll set it to 1 by default, and we'll multiply the rotation speed by rotation multiplier. Excellent. So what that means now is up here we can go look. We still need to gain access to the player's direction, so we'll grab that from chase target. Then we'll go look in direction, but we want to do only at maybe 0.2 of the rotation speed. So only 20% of the rotation speed. Now when we hit play, they should turn to face me, albeit at a slower rate, whilst they're telegraphing their attacks. Yes, that looks like it's all working. And to show how the object pool is working, over here in the hierarchy, you can see we've only got 10. Yet when I kill them, they just reset and use the same 10. Very efficient and optimized. You're not constantly instantiating and destroying objects over and over again. And no matter what, there will never be more than 10 because that's how the session has been set up. Just do a little bit of house cleaning towards the end here. I'm going to duplicate this display health, make it display timer. Remove this, set this to the timer variable. On the canvas, to make it work with all screen sizes, we'll set this canvas scale to scale with screen size and make it expand. Jump over to the health, we'll anchor it to the top left. We'll make this 256 by, say, 32. We'll align it to the top left. We'll move its Y position by -16 and its X by +16. Just give it a placeholder text there, and we'll set this to 24. Okay. Similar thing here, 24, anchor it to the middle top, 256, 32, -16. Okay. Timer. And we want to change the shared float here. Give it a private bool show as time. And we'll set that to false by default. Now down here, string display equals value.toString. Otherwise, if show is time, we need to do a little bit of math here. So int minutes equals mathf dot floor to int value divided by 60 for the seconds. We want to do modulo 60. And then we want to set display equal to minutes.toString with the format of 20, so that it gives it that time format of 01 to 10. And the same thing with the seconds, format 00. Then we just need to change this down here to display. Okay, save that. Jump back over to the editor, and there's one more thing we need to do that I noticed whilst playing before, and that is to jump into the enemy here. Move down to where we have the initialize statement. We need to set the telegraph visual.gameObject.setActive false, as halfway through this IEnumerator, if the object is released, it won't actually remove it here. By doing this, we ensure that as soon as the enemy is initialized, they're resetting that telegraph visual to invisible again. One other thing I also noticed upon review, we're not actually using this health max here. That should be getting set in this awake. Health equals health max. Little things that slip your mind while you're jumping around. But now, after compiling, if we hit play, we should see it all in action. Excellent. We got 5 minutes on the clock. Time to survive. If you find this interesting and want to follow along, please subscribe to my channel. If you have any questions, queries, or feedback, please head to the comments section and reach out. Thank you for your patience with this series. I'm currently in the middle of heavy assessment work in my course, so delays may continue in the short term. Thank you for watching.